Lesson 39, I will solve multiplication comparison word problems involving fractions. So today we're going to be talking all about word problems. So we're going to be using that strategy that we always use whenever we have an application problem. We're going to be thinking about R, D, W, W. So we're going to read, draw, we're going to write a multiplication sentence, and then we're going to write a sentence. So today we're not going to be doing our math journals today. We're going to be getting right to our problem set. I'm just going to tell you that I'm going to solve 4 of these problems with you, and I'm going to solve the last two too, but they're going to look just a little bit different. All right, so let's take a look at the first one, and let's talk about what expectations we're going to have whenever we are completing these math problems. We're going to model the problem. This is the part that most of you want to skip. You love to skip this part, but we're going to model the problem. Can you draw something? What can you draw, and what conclusions can you make from your drawing? We're really going to focus in on this part. We're not going to skip this. This is the part that you usually are really good about. Write an equation, write a statement of the answer. And then it's always important to think, does this make sense? That's assessing this solution for reasonableness. Does this make sense, my answer? Okay, that's really important also. All right, so let's take a look at problem 1. So Tamika ran 2 5/8 miles. Her sister ran twice as far. How far did Tamika's sister run? So remember, we're doing multiplication comparison problems. So when you hear words like ran twice as far, you know we're comparing. We're comparing Tamika to her sister. And we're saying that her sister ran twice as far. And we want to know, how far did Tamika's sister run? Well, whenever you are using a comparison problem, we use 2 tape diagrams. So we're going to put T for Tamika, and then we're going to put S for her sister. And we're going to start with one tape diagram here. This is going to be to model how far Tamika ran. Okay, so Tamika ran how far? Well, she ran 2 5/8 miles. We know that much. Now, it said her sister ran twice as far. So that means that her sister ran further. So notice my tape diagram is going to be larger. And when I make my tape diagram, I'm trying to make it twice as big as this one. So if I did like this, okay, if it's twice how far Tamika ran, then this would be 2 5/8, and this would be 2 5/8. Okay, now let's think about what we're trying to figure out. Are we trying to figure out how far they ran together? No, it just says how far did Tamika's sister run. So this is the part that I'm trying to figure out. Now I could solve this a couple of ways. I could say 2 times 2 5/8. Or what else could I do? I could do repeated addition, right? I could say 2 5/8 plus 2 5/8. I want you to choose which way you want to solve it. Then I want you to pause the video and I want you to solve this. Go ahead and come up with your answer and write your statement, and then let's come back and check together. Okay, so I'm going to go ahead and solve this using multiplication since I already have this written here. And I have 2 times 2 plus 2 times 5/8. So that's going to give me 4 plus 10/8. Well, 10/8 is an improper fraction, so I'm going to change this to 8/8 and 2/8. So that's going to be 4 plus 1 2/8, which equals 5 2/8. So how far did Tamika's sisters run? So I'm going to say Tamika's sister ran 5 2/8 miles. So let's think, does that make sense? If Tamika ran 2 5/8 miles and her sister ran twice as far, does 5 2/8 miles make sense? It does make sense. Now, if we said she ran 1 mile, that wouldn't make sense. If we said she ran 50 miles, that wouldn't make sense. But 5 2/8 does make sense. So let's take a look here for a minute at another model. So you can see that this is a model that someone else has drawn, and they did the same thing we did, 2 5/8, and then 2 5/8 2 times. Here's how they solved it like I did. If you chose to use addition, You could have also, if you chose to do repeated addition, 2 and 5/8 plus 2 and 5/8, you can see here they just separated the whole numbers from the fractions and they add the whole numbers together, which is 4 and 10/8. And when you look, it's this, when you get right here, it's exactly the same. We went from 10/8 to 1 and 2/8 and added it together. We still got the same answer, 5 and 2/8 miles. Okay, let's take a look at the next problem. Natasha's sculpture was 5 and 3/16 inches tall. Maya's was 4 times as tall. How much shorter was Natasha's sculpture than Maya's? Okay, so let's take a look here. What can we draw? Well, again, I'm hearing comparison words, like how much shorter, or Maya's was 4 times as tall. These are comparison words, so that tells me that I'm not going to just draw one tape diagram. I'm going to draw two so that I can compare the two. So I'm going to put N for Natasha and M for Maya. So I have one tape diagram to represent Natasha's sculpture. So how tall was hers? When I look back in the problem, I see that it was 5 and 3/16. Okay. Now, her sisters, or not, this isn't her sisters, that was the last problem, right? So, I'm going to group these together so that I can copy them. So, Maya's was 4 times as tall. So, what I'm going to do here is I'm going to clone this 4 times. You're just going to have to draw it 4 times. Sorry. I kind of have the advantage here with the computer. And then I'm going to put all 4 of these together. Okay, so I've got 1, 2, 3, and 4. So I want you to make sure that if you need to pause the video and get caught up with me, that you do. Okay, so now we have Natasha, and then we have Maya's, which is 4 times Natasha's. Now here's where you really have to think. What are we trying to answer? We're trying to answer how much shorter was Natasha's sculpture than Maya's. So where is that represented in our diagram? Where does it show how much shorter? Well, that's going to be this distance right here. We want to know how much shorter. What would this area right here be? What's the difference between these two? So how would you solve that? Well, there's a couple of ways we can do this. Typically, whenever you hear how much shorter or how much more or how much less, you always think subtraction. So we could solve to find out how tall Maya's sculpture is and then subtract Natasha's. But because all of these numbers are the same, can you look at this model and see how much more there would be in this space right here? Well, I see 5 and 3/16 3 times. So instead of using subtraction, couldn't I just solve for this right here and say 3 times 5 and 3/16? I think that would be a more efficient solution. You would probably, well, not probably, you would still get the same answer, but I'm just going to multiply 5 and 3/16 times 3. I also could add 5 and 3/16 3 times. So I've got 3 times 5 plus 3 times 3/16. So I want you to pause the video here, and I want you to go ahead and solve this by yourself. If you'd rather use repeated addition and add 5 and 3/16 3 times, you certainly can do that. But I want you to go ahead and solve the problem and see if we get the same answer. All right, so 3 times 5 is 15. 3 times 3/16 is 9/16. So that gives me 15 and 9/16. Because this is not an improper fraction, I don't have to do anything to it. So how much shorter was Natasha's sculpture than Maya's? So I can say Natasha's sculpture was 15 and 9/16 inches shorter than Maya's. Okay, so let's take a look at how they solved it. All right, so here you can look and you can see that they have the same model that we have. They have the comparison here. Here's Natasha, And here's Maya. She has 4 times as much. So their first solution is, look at what they did. They solved for Maya. So they went ahead and did 4 times 5 plus 3/16, which gave them 20 and 12/16. And then they subtracted 5 and 3/16 from 20, and that gave 15 and 2/16 because they subtracted the whole numbers. And then 12 minus 3/16. Oh, no, hold on. I see what they did. So they decomposed the 12/16 and the 15 and subtracted 12 minus 3, which is 9/16. So they got the same answer. So this is one solution. This is not the solution that we used. This is that solution where I told you that you could figure out the total of Maya's sculpture and then subtract this one. And here is the strategy that we used. They just said, hey, this is 3, 5, and 3/16, just like we did, and got the exact same answer. Okay, I feel like this way was much more efficient. This would have worked too, but it would have taken a little bit longer because it has a few extra steps. All right, let's take a look at problem 3. A seamstress needs 1 5/8 yards of fabric to make a child's dress. She needs 3 times as much fabric to make a woman's dress. How many yards of fabric does she need for both dresses? All right, so when you think for a minute, what could you draw to illustrate this problem? Are we comparing or are we making a total? Well, when I see words like 3 times as much, I know that I have a comparison here. So that means I'm going to need to model 2 tape diagrams. So I want you to pause the video here, and I want you to go ahead and draw the model by yourself. And if you think you can go ahead and solve the problem too, great, go ahead and solve the problem, and then you can come back at the end and we'll check together. If you get stuck, don't sit there for 10 minutes. Go ahead and press play, and I'll explain it to you. Okay, so hopefully you paused the video and you're ready to check. If not, I want you to pause the video and try to do it by yourself. Come back if you get stuck. All right, so we're going to compare a child's dress to a woman's dress. So I've got C here and W here. So for a child's dress, she's going to need 1 5/8 yards. So I'm going to go ahead and put this here, 1 5/8. And then for the woman's dress, she's going to need 3 times as much. So I'm going to go ahead and make 3 tape diagrams here. Okay, so these are supposed to be the same size. They're close enough. All right, so this is going to be 1 5/8. And then for the woman's dress, I've got 1 5/8 3 times. Now let's look at what the question is asking. It's not asking how much fabric do you need for a woman's dress. It's asking how many yards of fabric do you need for both dresses. So in this case, this is where my question mark would be. This is how much I'd need for both. So how could I solve this? I could solve for the woman's dress and then add it to the child's dress. But when I look at my model, I've got 1 5/8, 1 5/8, 1 5/8, 1 5/8. So I'm thinking that a more efficient way to solve this would be to say 4 times 1 5/8. If that's not how you solved it, that's okay. Don't panic. Let's see if we got the same answer. But let's make sure that you understand what I did here. I've got 1 5/8 for the child's dress, and I've got 3 1 5/8 for the woman's dress. So I'm just going to say 4 times 1 5/8, which is the same thing as 4 times 1 plus 4 times 5/8. So that gives me 4 plus 20/8. So I'm going to take this improper fraction and I'm going to make a number bond here to change this into a mixed number. So if I counted by eighths, I would get to 16/8, and then I would have 4/8 left over. So that gives me 4 plus 2 and 4/8, which equals 6 and 4/8. So how many yards of fabric does she need for both dresses? She needs 6 and 4/8 yards for both dresses. All right, So let's take a look at their solution. So here's our same tape diagram. They got the same answer, 6 4/8. So let's take a look at this one. So in the first solution, they solved for the woman's dress. So they did 3 times 1 5/8, and they got 4 7/8. This may be how you chose to do it. And then they took that and they added it to the child's dress, which gave them 6 4/8. I chose to do 4 times 1 5/8, and then I got 6 4/8. So it doesn't matter which of these solutions you chose, they still got the same answer. All right, let's take a look at problem number 4. A piece of blue yarn is 5 2/3 long. A piece of pink yarn is 5 times as long as the blue yarn. Bailey tied them together with a knot that used 1/3 yard from each piece of yarn. What's the total length of the yarn tied together? Okay, so this was a little bit more complex. All right, so let's think here for a minute what we could do to solve this. Okay, so first of all, I'm hearing some comparison words. I'm going to need to figure out how long this pink piece of yarn is, right? So I've got blue, which is 5 2/3. And then I've got this pink yarn, which is 5 times as long. So I'm going to go ahead and make this 5 2/3. And how many times do I have to do that? Well, I have 5 of them, so I will have to clone this 5 times. You can go ahead and pause the video. Whoops. You can go ahead and pause the video and go ahead and draw your model and then come back and compare yours to mine. Okay, so now we have our model. So let's think about what we're trying to find out. It said she tied them together. And we want to know what's the total length of the yarn tied together. So first of all, let's figure out how much this is together. Then we can deal with how much of the yarn that she used to make the knot, okay? Because it looks like she used 1/3 of the piece of yarn from each piece. So let's go ahead and find the total first, okay? All right, so how could I find the total? Well, I could find the total of the pink yarn. I put Y for yarn, but it should be P for pink. And then I could add together the blue yarn. But because I've got 5 2/3, 1, 2, 3, 4, 5, 6 times, I think it'd be faster just to say 6 times 5 2/3. And this is going to give me a total for the yarn. So 6 times 5 2/3 is the same thing as 6 times 5 plus 6 times 2/3. This is going to be 30 plus 12/3. Well, because 12 divides by 3 evenly, I can say that's 30 plus 4, which equals 34. But this isn't the answer. Okay, this tells me what it is total, but I still need to take away how much how much of the yarn she used for the knots. She used 1/3 of yarn from each piece of yarn. So there's 2 pieces of yarn. So she took away 1/3 from the blue and 1/3 from the pink. So how much did she take away altogether? Well, she took away 2/3. So I could go back a step here. Like I could take this and say, how am I going to get 34 minus 2/3? Probably the easiest way to do that would be to say, okay, well, I'm going to take one whole and change it into 3/3 like this. And then I can say, all right, take 2/3 away from 3/3, which gives me 1/3, and then add that to the 33. So I've got 34 minus 2/3 is 33 3/3 minus 2/3, and that equals 33 1/3. So what's the total length of the yarn tied together? The total length is 33 1/3. And are we talking about yards here or feet or inches? Let's go back up here and look. We're talking about yards of yarn. Okay, so we have 2 more problems left. And for the next 2, they're going to kind of look like this. And that's okay. They're still the same problems. All right, a truck driver drove 35 and 2/10 miles before he stopped for breakfast. He then drove 5 times as far before he stopped for lunch. How far did he drive that day before his lunch break? Okay, so I'm hearing some of those comparison words like 5 times as far. So let's talk about, let's say, before breakfast and then before lunch. Okay, so before breakfast, he drove 35 and 2/10 miles. And then it said before lunch, he drove 5 times as far. So we're going to have 35 and 5/10 5 times. I'm going to go ahead and divide this into 5 parts. And then I've got 35 and 2/10 5 times here. Now, while I'm doing this, let's go ahead and start thinking ahead to what is this problem asking us? Where's the question mark go? Well, this is how far he drove before breakfast, and this is how far he drove after breakfast or before lunch. So we want to know a total. So our total would look like this. How much altogether? So I want you to choose a strategy. I want you to pause the video, and I want you to solve this. If you get stuck, press play, but I think you can do this by yourself. There's more than one way to solve this problem. Okay, so hopefully you tried to solve this by yourself. Now, I could say, how far did he drive before lunch? And then add that to how far did he drive before breakfast. If that's what you did, that's a great strategy. I see 1, 2, 3, 4, 5, 6, 35 and 2/10. So I'm going to do 6 times 35 and 2/10, which is going to be the same thing as 6 times 35 plus 6 times 2/10. So typically I can do these in my head. I'm going to go ahead and come over here and do 35 times 6. 5 times 6 is 30. 3 times 6 is 18, plus 3, 210. So I'm going to have 210 plus 12/10. This is an improper fraction, but it's a pretty easy one to make into a mixed number because I would have 10/10 and 2/10. So that's going to give me 210 plus 1 and 2/10, which equals 211 and 2/10. So how far did he drive that day? So we can say he drove 211 and 2/10 miles before lunch. Okay? If you didn't solve it this way, but you still got the same answer, then that's fine. There's always more than one strategy to solve it. I felt like this would be the most efficient, and it made the most sense to me. Okay, we've got one more problem. I want you to be really brave here today, and I want you to pause the video, and I want you to read through this and do as much of it as you can by yourself. If you can do the whole problem, great. If not, if you can just do half of it by yourself, that would be great. I want you to try to do some of it by yourself. And then I want you to come back, and we'll work through it together. Okay, so hopefully you attended this problem by yourself. I'm going to use that RDWW process. I'm going to begin by reading it. Mr. Washington's motorcycle needs 5 5/10 gallons of gas to fill the tank. His van needs 5 times as much gas to fill it. Mr. Washington pays $3 per gallon for gas. How much will it cost him to fill both the motorcycle and the van? So I'm hearing some of those comparison words. So I'm going to start with the motorcycle, and then I've got the van. So the motorcycle takes 5 5/10 gallons to fill with gas. And it says that the van takes 5 times as much. So I'm going to go ahead and clone this 5 times. So I've got 1, 2, 3, 4, and 5. Oops, wrong one. And 5. Now, I've got to figure out what this problem is asking me. I'm filling up both of these vehicles, and it's $3 per gallon. So I'm thinking this is a two-step problem. And in the first step, I want to know how many gallons of gas he needs first. So this is what I'm going to solve for first, a total. Now I could find a total for the van and add it to the motorcycle, but because I see 5 and 5/10, 1, 2, 3, 4, 5, 6 times, I'm going to say 6 times 5 and 5/10 will give me a total of the number of gallons. So this would be 6 times 5 plus 6 times 5/10. So 6 times 5 is 30, and 6 times 5/10 is 30 tenths. Together, this equals 30 plus, this right here would be a total of 3, equals 33. So I need 33 gallons. Now it says it's $3 per gallon. So that means I would have 33 times 3. So if I did 33 times 3, that would be 99. So how much will it cost him to fill both the motorcycle and the van? It will cost $99 to fill both. Okay, so remember, there's more than one way to solve these problems, but if you're getting the same answer, it's okay no matter how you do it. Just remember that it's always important to not skip the draw. It's very important to help you to understand how to solve the problem.